there is an important question: what is the thermodynamic state, process, and cycle, and what are their significances? So let me first tell you what is a state. As you can see, there are three states: 1, 2, and 3. How do we define a state? State is a condition of a system at a particular instant of time at which its properties are defined. What I have said. What is a state? State is a condition of a system at a particular instant of time at which its properties like pressure, volume, temperature are defined. So this is what we call as state. What is its significance? See, state does not show any change in property. For example, you cannot find out change in property at particular point 2. You cannot find out the change in pressure, the change in volume. You can find out a single property, or you can say the property at instant, like what is P1, what is P2, what is V1. So you can find out not the change in property. It does not show the change in property, but it shows the property at instant. So what is the significance of state? See, it defines the system at equilibrium. What it does is it helps us in defining our system at equilibrium, because it tells us the properties at a particular point, and that point is nothing but the equilibrium. Next comes, what is the process? See, process is the change in state, and what you can say is change in state of any system or gas as a result of flow of energy. What have I said? Process is nothing. It is the change in state of a gas as a result of flow of energy. If there is any flow in energy, then there will be some change in the state of the system. That means its property will change, and that change is very much represented by process. Now, what is the significance of this process? See, it helps us in measuring the energy interaction. If you have read first law of thermodynamics, so with that you can find out what is the energy interaction. That means what is the heat interaction or work interaction for particular process, let's say 1, 2. So process helps us in measuring the energy interaction for a system. And the final one we have here is cycle. What is cycle? The cycle is the combination of different processes like 1, 2, 2, 3, and 3, 1 is making 1, 2, 3, 1 cycle. So what is cycle then? Cycle is a combination of different processes in which initial property of a system is same as that of final property of the system. So this is our cycle. Now, what is its relevance? What is the significance of cycle? See, one thing you can understand, that even if you draw PV diagram or you draw Trias diagram, for both of them you will have this thing same, that net heat interaction is equal to net work interaction, or net heat transfer is equal to net work transfer for both the cycles, whether you draw the same cycle in PV or in TS. Now, how can we say that? You can see a basic proof here. You know the first law of thermodynamics. What is it? dq is equal to du plus dw. You can define this same for 1 to 2 process, and 2 to 3, and 3, 4. If you add them all, one thing you can find out here is that for any cycle there is no change in property, right? As we have said that for a cycle the property remains same. The initial property of the system, if it is P1, V1, T1, then it will be same as that of final property of the system in a cycle. So as we have one is as the initial and the final state of the system in a cycle, then we can say that there is no change in property, right? So if there is no change in property, if I define internal energy as it is a point function, so there will not be any change in internal energy of a system which goes through the cycle. So net internal energy interaction will be 0. Okay, so therefore we can say the heat transfer, the net heat transfer is equal to a net work transfer. The cyclic integral of heat transfer is equal to cyclic integral of work transfer. Why cyclic integral? Because we are defining this for the whole cycle. There is another significance of cycle, which is that we can define the efficiency of a particular engine by applying the first law of cycle. So as we have find out the first law for a cycle, now we can define this for an engine. If you have an engine, what you can write here is first you can write that net heat transfer is nothing but Q1 minus Q2, and net work transfer is nothing but work we have obtained during expansion minus work we have given to the engine during compression. So you can see here the heat transfer, which is Q1 minus Q2, and the work transfer, which is WE minus WC. As per the sign convention, we have taken the signs here. So next we can also say that from the first law of cycle, as we know, net heat transfer is equal to net work transfer. Therefore, we can write Q1 minus Q2 is equal to WE minus WC. This is our first equation. Now you can define the efficiency of the engine. What is it? Output upon input. What is output? The net work that we are getting. And what is input? The net the heat that we have given to the engine. So this net work will be equals to WE minus WC, right? The net work will be equal to WE minus WC. And what is the Q1? Q1 is Q1. As we know from first equation, first Q1 minus Q2 is equal to WE minus WC. Therefore, we'll put here, we'll replace this value of WE minus WC by Q1 minus Q2. So therefore, we can get the efficiency of the engine.